Hello, welcome back. So we are going to talk about probability distributions, right? But before that, I want to briefly take a look at discrete random variables. Discrete random variables. So when we are working with probability distribution, you can either be working at discrete random variables or you can be working with continuous random variables. Right, the discrete part really means that there are countable or definitive values. There are the steps, they are countable. So if let's say there are, sorry, that was my alarm. If you take example of a die, one side has 6, one side has the value 1, 2, 3, 4, 5, 6, right? So all the sides have some certain value 1, 2, 3, 4, 5 and 6, and these are steps. They aren't continuous, that you can also have 1.5 and you can have anything between 1 and 2, nothing like that. You will either have 1 or you will have 2, right? So that's what discrete means. And what random really means is that you aren't biased in picking what value you get. So taking the example of a die, you can just say the die is unbiased. Or if let's say you have a refrigerator and there are certain ice creams in there, let's say 30 of them are orange and 70 of them are blue, right? And they're all mixed together, they're perfectly mixed together, and you just put your hand in there and you take one out. There will be a 70% chance that you get a blue, 30% chance that you get an orange, simply because you are choosing randomly, right? So let's come to probability distribution. So probability distributions, right? One thing here is that discrete random variables, if let's say x is some discrete random variables, I can say that x is an element of, well, if I take the example of a die, x would be an element of 1, 2, 3, 4, 5, 6. What this means is that this certain variable x can be 1, 2, 3, 4, 5 or 6, nothing else, right? So let me go ahead and draw a table. And actually let's take a different example. Let's say there's some circular disk, and of which 50% of the area has the score 0, 25% has 1, 25% has 2, and there's a certain pointer over here, right? So let me redraw this because this looks like equally divided, right? So 50% has 0, 25% has 1, 25% has 2. So in this case, the variable x can either be 0, can be 1, or it can be 2, right? And what is the probability of x equaling 0? Well, 50%, if you're spinning it randomly, 50% of the time it should land up on 0. So the probability is 0.5. For 1 it will be 0.25, similarly for 2 it will be 0.25, right? If when I say probability of x equaling some certain x, what I'm really saying is that this random variable, what is the probability that it equals 0? And that is 0.5, right? And one thing to notice here is that if I add all of these, this will give me 1, simply because x will be either 2 or 1 or 0, and it can be nothing aside from that, right? So anything that comes out will be either 0, 1 or 2, right? So one thing is you will need to see the link between probabilities and expected frequencies, right? So if I spin this disk 100 times, what would be my expected frequency? Well, if my chances of getting 0 is 0.5 at every turn, and I am turning it 100 times randomly, there's 100 times 0.5 chance, 0.5 value. So 100 times 0.5 is 50, 100 times 0.25 25, and here also 25, right? So what I'm really explaining is the formula that expected frequency is number of trials times the probability of x equaling that value, right? So frequency of some x. So here what you will notice is this is equal to 100, because every expected value is scaled up 100 times. So 100 times the probability of x equaling 0 plus 100 times probability of x equaling 1 plus 100 times probability of x equaling 2. I can just factor out the 100, and I know the sum of all the probabilities is 1, right? So what I'm getting here at is basically that probabilities are just relative frequencies, right? The expected frequencies have a certain number of turns, certain number of trials, if you look at them relatively, that I conducted 100 trials, out of them 50 came out to be 0, was 50, yeah, 50 came out to be 0. So looking at relatively, 0.5% of everything, of all the values were 0. 50% of the time I got 0, right? So that's what probability basically is. Now what we will see basically now is that that the mean, if you have some data, the mean is basically the sum of frequency times that x over the sum of frequency, right? Because that's how mean is. So if this is of course one formula to calculate mean, the second formula that is basically the same thing is probability times x times the probability of x equaling that x, and sum them all up, right? So one thing to notice is that the mean, no matter how many times you carry out the trial, the expected mean never changes. It should not change. And we know that probability is basically relative frequencies. So if I basically say this as sum of x times probability over sum of p, well, I know sum of p is just 1, so I can ignore this and say simply sum of xp and x equaling x. So to give you an example of this, what we really do is that we look at x, we multiply it with the probability, and we sum them all up. So 0, the mean or the expected value of this would be 0 times 0.5 plus 1 times 0.25 plus 2 times 0.25, and this would turn out to be, I think, 0.75. Yep. Let me erase all of this. And if you were looking at the frequency formula, what you would really be doing is multiplying it by 100 over 100, right? So if you did sum of fx over sum of f, right, what you would be doing is, well, 100 times 0.5, which basically give you the 50, times 0 plus 100 times 0.25 times 1 plus 100 times 0.25 times 2, all divided by 100. Now if I take the 100 common, you get the same thing, that is 0.5 times 0 plus 0.25 times 1 plus 0.25 times 1 over 100, and this basically cancels out, right? And so you're left with the same formula, that the mean is sigma x p of x equaling x multiplied by the probability of that happening, right? So that's the mean. If we now look at variance, you know that variance is, so if I don't have probabilities, if I don't have frequencies, instead if I have probabilities, if I just convert this, what I will get is sigma x squared p over sigma p minus sigma xp over sigma p square. But I know that the sum of all the probabilities is 1, so we can just ignore it and write down the formula, that it is the sum of x squared p minus the sum of xp squared, right? So if we take this certain example, I should copy the board over here. So we will look at the square of x. So 0 squared 0, 1 squared 1, 2 squared 4, and then we multiply it with its probability. So 0 times 0.5 plus 0.25 times 1 plus 4 times 0.25. This should give me 1.25. So sum of x squared p is 1.25. Sum of xp we found out to be 0.75. So 1.25 minus 0.75 will give you 0.5, and so we know that variance is 0.5, and we know that variance is the square root of standard deviation. So standard deviation is under root 0.5. So what this value really represents is how spread out the data is. If my variance is very huge, what it means is that the values are very spread out. If my variance is very small, what it means is that most of the values are around a small range, right? And that's it for today's probability distributions, right? Connecting frequencies with probabilities and coming up with the formula of mean and variance. All right.